What if I told you that right now, just 18 light-years away from us, there exists a planet that could completely change our understanding of life in the universe? A planet so incredible that when scientists first received data about it, many refused to believe what they were seeing. Welcome to our channel, where we explore the most amazing mysteries of space. Today we'll embark on a journey through the most enigmatic worlds of our galaxy, exoplanets that force scientists to reconsider fundamental laws of physics and planetary formation. Over the past 30 years, humanity has discovered more than 5,000 planets beyond our solar system, but among them are worlds so unusual that they seem to come straight from science fiction. Planets made of pure diamond, worlds with rain of molten glass, lonely wandering planets in interstellar void, and planets with conditions so extreme that they challenge our understanding of what's even possible in nature. Get ready to learn facts that will make you look at space and our place in it in a completely new way. But first, subscribe to the channel and hit the like button if you want to learn more amazing facts about the universe. To understand how amazing modern discoveries are, let's go back to the beginning. Before 1995, the existence of planets beyond our solar system was merely a theoretical assumption. Astronomers logically supposed that if planets orbit our sun, they should exist around other stars too, but there was no proof. Everything changed on October 6, 1995, when Swiss astronomers Michel Mayor and Didier Queloz announced the discovery of the first exoplanet around a Sun-like star to 51 Eridani b. This discovery, awarded the Nobel Prize in Physics in 2019, opened a new era in astronomy. But even the first exoplanet brought a surprise. It was a hot Jupiter, a gas giant orbiting so close to its star that it completes a full orbit in just 4.2 Earth days. According to our understanding of planetary formation, this shouldn't have been possible. Gas giants form far from stars, where it's cold enough for ice and gases to condense. Since then, each new discovery has brought increasingly amazing surprises. Today we know of planets ranging in size from Mercury to objects several times larger than Jupiter. We've discovered planets composed of water ice, lava, metal, and even diamond. And this is just the beginning of our journey into the world of exoplanetary wonders. In 2019, the TESS Space Telescope discovered an exoplanet that literally blew astronomers' minds. This planet, designated TOI 849b, is located in the constellation Pictor at a distance of 730 light-years from Earth. What makes this planet so special? Imagine a celestial body almost the size of Neptune, with a radius of 3.4 Earth radii, but with a mass only 40 times greater than Earth's. For comparison, Neptune, with a similar size, weighs 17 times more than Earth. This means TOI 849b has a density 2.5 times lower than it should have at such dimensions. But the most astounding thing is the planet's composition. Spectral data analysis showed that TOI 849b consists almost entirely of rock and metal, with virtually no gaseous envelope. It's like discovering a truck-sized car made of foam-density material. According to all laws of planetary formation, an object of this size should have accumulated a huge gaseous atmosphere of hydrogen and helium, becoming a gas giant like Neptune or Uranus. But TOI 849b has virtually no atmosphere, just a thin layer comprising less than 4% of the planet's total mass. Scientists propose several theories. Perhaps this planet was once a full-fledged gas giant, but extreme radiation from its nearby star literally blew away its atmosphere. Or it might be a failed gas giant core that for some reason couldn't accumulate enough gas during formation. The surface temperature of TOI 849b reaches 1800 degrees Celsius, hot enough to melt copper. The planet is so close to its star that a year there lasts only 18.4 Earth hours. If TOI 849b amazes with its structure, then planet PSRJ 17191438b surprises with its composition. This exoplanet, discovered in 2011, literally consists of diamond, the hardest natural material in the universe. Located 4,000 light-years from Earth in the constellation Serpens, this planet orbits a pulsar, an ultra-dense remnant of an exploded star. Pulsar PSRJ 17191438 rotates at 173 revolutions per second, emitting regular pulses of radio radiation. The diamond planet's diameter is about 60,000 kilometers, 5 times larger than Earth, but its mass only slightly exceeds Jupiter's mass. This means the planet has very low density for a solid body, which indicates its crystalline structure. How did this cosmic gem form? Scientists believe it was originally a white dwarf star in a binary system. When its companion star exploded as a supernova, the resulting pulsar began gradually consuming the white dwarf's material. Under the influence of monstrous gravitational forces and temperatures, carbon in the former star's core crystallized, turning into a giant diamond. It's interesting to calculate such a planet's value. At current market prices for diamonds, about $60,000 per kilogram of quality diamond. Planet PSRJ1719143 would be worth approximately $26.9 nonillion, a number with 30 zeros. That's trillions of times more than the global GDP. But mining such a treasure remains in the realm of fantasy. The planet exists in extreme conditions near a pulsar, where radiation is millions of times higher than the lethal dose for humans. Among all known exoplanets, HD 189,733b arguably has the most terrifying climatic conditions. This planet, located 63 light-years away in the constellation Vulpecula, represents a true climatic hell. HD 189,733b is a Jupiter-sized gas giant orbiting so close to its star that it completes a full orbit in just 2.2 Earth days. The temperature on the planet's illuminated side reaches 1,200 degrees Celsius, while the dark side is only 800 degrees. But temperature isn't the most frightening thing on this planet. Wind's blow here speeds up to 8,500 kilometers per hour. That's 20 times faster than the speed of sound. For comparison, the most powerful Earth hurricanes rarely exceed 300 kilometers per hour. And the most insane part, it rains molten glass on HD 189,733b. The planet's atmosphere is rich in silicates, which under extreme temperatures and pressures form microscopic glass particles. These particles are caught up by supersonic winds and carried through the atmosphere like cosmic sandpaper. Interestingly, despite the hellish conditions, HD 189,733b has a beautiful deep blue color, very similar to Earth's color from space. This color is caused by light scattering by silicate particles in the atmosphere, the same effect that makes Earth's sky blue, but with far more dramatic consequences. Studying HD 189,733b helps scientists understand atmospheric dynamics of extreme worlds and develop models for searching for more hospitable exoplanets. Among the most mysterious objects in the universe are rogue planets, worlds that don't orbit any star, but freely drift through interstellar space. These cosmic orphans represent a completely new class of celestial bodies. The first rogue planet, CFB-DSIR 1490403, was discovered in 2012 at a distance of about 100 light-years from Earth. This Jupiter-sized object drifts in the complete darkness and cold of interstellar space at a temperature of minus 230 degrees Celsius. How can a planet exist without a star? There are several theories about their origin. The first suggests these are planets that were ejected from their home planetary systems as a result of gravitational catastrophes, close encounters with other stars, supernova explosions, or gravitational interactions with more massive planets. The second theory states that rogue planets could form independently from the collapse of gas dust clouds, like failed stars. Such objects are called sub-brown dwarfs. They're too massive to be planets, but not massive enough to become stars. Recent studies using gravitational microlensing have shown a stunning result. There may be more rogue planets in our galaxy than stars. According to some estimates, between 50 billion and to trillion such lonely worlds drift through the Milky Way. A particularly intriguing possibility is the existence of rogue planets with subsurface oceans. Even without starlight, radioactive decay in the planet's core and tidal friction could maintain liquid water under an icy crust, similar to Jupiter's moons Europa and Enceladus. Such worlds could theoretically support life in complete isolation from starlight. Star Wars fans remember the breathtaking scenes of binary sunsets on planet Tatooine. For a long time, such worlds were considered pure fiction, but in 2011, the Kepler Space Telescope discovered a real planet with two suns. Kepler-16b, dubbed the Tatooine planet by scientists, is located 245 light-years from Earth in the constellation Cygnus. This Saturn-sized planet orbits a binary star system consisting of an orange dwarf and a red dwarf. The orbital mechanics of such systems are staggering in their complexity. Kepler-1 completes a full orbit around the binary star in 229 Earth days, while the stars themselves orbit each other every 41 days. This creates incredibly complex gravitational dynamics that were long considered unfavorable for planet formation. The temperature on Kepler-1 ranges from -73 to -101 degrees Celsius, and the atmosphere consists mainly of hydrogen and helium. Life as we know it would be impossible on such a planet, but the spectacle of binary sunrises and sunsets would be truly unforgettable. Since the discovery of Kepler-1 astronomers have found more than a dozen planets in binary star systems. Some of them, such as Kepler-453b, are located in the habitable zones of their stars, where liquid water could theoretically exist. Among the most dramatic exoplanets stands out WASP-1b, a world that is literally being devoured by its star. This planet, located 871 light-years from Earth, is a gas giant in the deadly embrace of its sun. WASP-1b orbits so close to its star that it completes a full revolution in just 26 hours. At such proximity, the star's tidal forces literally tear the planet apart. The star's gravity deforms the planet, giving it an egg shape and pulling streams of hot gas from it. The temperature on the planet reaches 2,500 degrees Celsius, hot enough to melt iron. At such temperature, the planet's atmosphere exists in a plasma state and actively evaporates into space. Scientists have calculated that WASP-1b loses about 6 billion tons of mass per second. This process of the star eating the planet doesn't go unnoticed. The planet enriches the star with heavy elements, changing its spectral composition. In 10 million years, WASP-1b will completely evaporate, leaving behind only a small core. Studying such dying planets helps understand the fate of planetary systems and stellar evolution. Moreover, it reminds us how fragile the balance in planetary systems can be. Not all exoplanets are hellish worlds. K218b, located 124 light-years from Earth in the constellation Leo, may prove to be one of the most promising candidates in the search for life. This planet, 2.6 times larger than Earth in size and 8.6 times more massive, orbits in the habitable zone of its star, red dwarf K218. In 2019, the Hubble Space Telescope detected water vapor in the planet's atmosphere, the first confirmation of water in the atmosphere of a potentially habitable exoplanet. Further observations with the James Webb Space Telescope in 2023 brought even more sensational results. Traces of dimethyl sulfide were discovered in K218b's atmosphere, a molecule that on Earth is produced only by living organisms. However, scientists urge caution. K218b is likely a high CN world, a type of planet with a deep ocean under a hydrogen-rich atmosphere. Such conditions are vastly different from Earth's, and life there, if it exists, could have a completely different nature. The temperature on K218b ranges from -73 to +46 degrees Celsius, making liquid water possible. The planet receives approximately the same amount of stellar radiation as Earth does from the Sun, despite its star being cooler than our Sun. Our journey through the most amazing worlds of the galaxy is coming to an end, but discoveries continue every day. Over 30 years of studying exoplanets, we've learned that the universe is full of worlds so diverse and unusual that they constantly force us to reconsider our ideas about what's possible in nature. We've seen diamond planets and worlds with glass rain, lonely wandering planets and planets with two suns, worlds being devoured by their stars, and planets that may harbor life in forms we are only beginning to imagine. Each of these discoveries not only expands our knowledge of space, but also helps us better understand our own planet and its place in the universe. Earth, as it turns out, may be much more unique than we thought, but at the same time we see that the diversity of planetary worlds is practically limitless. The new James Webb Space Telescope has already begun a revolution in exoplanet studies, allowing us to analyze the atmospheric composition of distant worlds with unprecedented precision. In the coming years, even more powerful telescopes are planned for launch, which will be able to take direct images of exoplanets and search for signs of life. Perhaps among the billions of exoplanets in our galaxy, we'll find not only strange and extreme worlds, but also planets similar to Earth where life could have developed. Or perhaps the most amazing discoveries are still ahead of us. What do you think? Which of these planets seemed most amazing to you? Do you believe we'll find life on exoplanets in the coming decades? Write in the comments, and don't forget to subscribe to the channel so you won't miss new videos about the mysteries of the universe. See you in the next episode, where we'll continue exploring the most incredible secrets of space.